Hi, John, and this is Jan Feng from SD3A. In this screen call, I will discuss the system architecture of my individual RoadEase IoT project. My goal is to design a reverse parking system that use ultrasonic sensor to identify the distance to an object and keep the car at a safe distance from the object. um, Build a system that effectively uh, integrates IoT hardware, web server, cloud storage, and the secure data transmission, and such as the monitoring distance and then triggering the alarms like the buzzer. And I would detail how those components work together and the measure we talk to ensure data security. So the IoT hardware, the hardware include the ultrasonic sensor, this one, and the RGB LED, this one, and the buzzer. So they are connected to Raspberry Pi with acts as a central control for data collection and processing. So the ultrasonic sensor measure the distance, and based on the command, Raspberry Pi triggers a section like LED on or off, or turn on the monitoring or turn off the monitoring, like that. And the ultrasonic sensor is connected to GPIO pin 23 and 24 for trigger and echo respectively. And the sensor measure the distance. If the distance is below 20 centimeter, the buzzer activates and the LED turn up right. Turn up right. And the RGB LED is connected to the GPL pin 17, 20, 27, and 22 for the red, green, and blue. Yeah, for the here. And the lights can be turned on manually. So the buzzer is connected to the GPL 18. Yeah, GPL 18, this one. Okay, right now I'm gonna test my sensors. So let's say turn on the LED, then you can see the LED on, and turn off the LED off. And turn on the monitor distance. Yeah, the green lights means like it's a safety distance. So if I close to the ultrasonic sensor, it show the red lights, which means too close. The web server is built with Flask and hosted on AWS EC2 instance services, and the server runs on Ubuntu and is configured with HTTP port 80 and HTTP port 443 for secure communication. And this is the port 80 HTTP, and then this one is for the HTTPS 443, and also to achieve this, Apache 2 is used as a web server software and a WSGI file. This one is configured to server the Flask app. And the to ensure security communication, the HTTP is implemented for all data transfer between Raspberry Pi web server and the users accessing to the system. So let's encrypt, and certificate is configured on the Apache server hosting the application. I also applied for this SSL certificate for the domain name, which protects the domain and the private data intercorruption. So you can see the app is HTTPS. About the database, I use MySQL to store the data collected from the sensor. I use encryption to protect the static data. Like this is my database. So if I want to access my database without any password, then you have no permission to access it. So I have to tap my right password, which is so this is the right password. I can access my database right now. So let's see, use my database and to see the sensor, the users, all users. Yeah, so you can see this is my Google account. That's others. This is also mine. So if someone want to browse the data, they can't read it without the password. So the last part is using Pablo as our communication platform to enable real-time messaging between IoT hardware and AWS. This ensures that data collected by sensor is secured and transmitted to a networking server for processing and storage. It provides encrypted channel and access manager capabilities, and this ensures that only authorized user can publish or subscribe the specific channels and further enhancing our security posture. Okay, here I'm gonna show you how to use my website. So first of all, we must use the Google account to log in to my website. If you don't log in, you can't browse the older filters like and car, daily news, or cars. So if I click the cars without the login, then you can see you can't browse. It's unauthorized. So if we want to access the car, we have to sign in with Google. Yeah, now it's sign up successfully, and after sign up, and this is a new news page. Like the website is not only a distance monitoring website, and it can also see the latest news. And this is actually a news API which I built into the project, and you can access the news from the world and or technology, health, finance. So there are different type of news that you can search by the users themselves, and entertainment, and so on. And this is the navbar. I set myself as an admin, so I can see the dashboard, and this is the logged in user. So if I'm not the administrator, it will not see the dashboard. Like, so if it's not an administrator, it will not see the dashboard. And this is my another account, another Google account, and there is no dashboard button. So this user cannot see the logged in user. Yeah. Okay, so here I'm gonna add a new car. Like this is the form for add a new car. Fill in some basic car information and image to it. So let's say Ford and year like 2010. Tab maybe SUV engine, like electric, like menu. Car is color maybe red. Yeah, and the image for it and car. Yeah, right now and you can see this car is I just ended, and you can also see from the database. Yeah, the ID 9 Ford 2010 SUV electric manual red and has been ended. And yeah, and here is also a message to tell you that the car was ended successfully. And in addition, I'm the administrator, so I can see all the cars ended by all users. So the normal user can only see the car they have ended by themselves. Like this is my another account, so the user can only see the car ended by himself. And then here's the delete button, which can also delete car from the database. So let's try delete. Okay. Yeah, and there's the information say car deleted successfully, and we can also see from the database. Yeah, you can see the ID now has been deleted. And let's check on, and we can click on the car image. Then you can see that this is the key feature page. I can see the car image ID and the real-time distance data and the LED control button. Turn on the LED, turn off the LED. So I can control the on and off. Maybe just let's try it to run the code in my Pi. Yeah, you can see listening for messages on PubNode channel, and I can click turn on and stashes LEDs on and turn off the LED statue LED is off. And here you can see the command in show here, and also turn on the monitoring. You can see the real-time distance state data is show up. And if I just try, yeah, if too close, then it also change and turn off the monitoring. And yeah, and I can also click the check privacy data to see data I have collected in the past. And this is all the data I have. It's too much, right? So if you want to see a specific time range, then you can search the data by time and date. Like just try maybe 11th of January and time range from 12 o'clock in the morning. and to today, maybe, yeah, it's a real time right now. Maybe just click that and filter. Yeah, you can see that's the data I have collected from 11th, and this is the data I just get it. And so yeah, you can filter the data by the time range. And yeah, I think this is all the future of my project. Okay, thank you, John, for listening my discuss of my project. Thank you.